Welcome to this short tutorial on Multisim. For this tutorial, we're going to be using Multisim 14.1, and what we're going to have a look at is a quick overview of the application and where to find each of the components that we'll be using. We'll build a simple circuit, how to construct it and connect it up, and then some instrumentation. We'll have a quick look at a multimeter and an oscilloscope. We'll connect those up across our circuit, and then we will also run the simulation and have a look at some readings of it. Okay, so just an overview of the application and where we can find each of the pieces that we need to construct our circuit and then to use the instrumentation. So up towards the top here, we have this toolbox along here. This toolbox is our components toolbox. From here, we'll be able to select our resistors, our capacitors, our inductors, all of the different components that we want to build our circuit. Just to the right of that here, then we have our simulation toolbox, where we can run our simulation and end our simulation. And further along to the right here, then we have our probes. So we can put probes onto the circuits when we build them, and we might introduce one of these later on. And that'll give us some information just at that point of the circuit. Okay. For our instrumentation purposes, though, we will be using the instrumentation toolbox, which is over to the right hand side here. Okay, and down along here, you can see that if you mouse over each of these, you can see that it'll bring up the item name. So we have a multimeter, we have a function generator, a watt meter, an oscilloscope, and a 4-channel oscilloscope. So the oscilloscope itself here, that's a standard 2-channel oscilloscope. And we have lots of other equipment here, including different types of oscilloscopes down here. So we have an Aglient and a Textronics oscilloscopes there as well. If you're more comfortable with those, you can use those. And finally, down the bottom here, we have a current clamp, which we may use to measure current in the circuit via the oscilloscope. Okay, let's start to build a small circuit here. So I'm going to build a simple RL circuit here, okay, with an AC power source. So along the component toolbox up here, you'll see that I can place a source, some basic components, diodes. Okay, but once I click on these, it opens up a component window for us. And it doesn't essentially matter which one of these I click because the component window will open. And in here on the component window, under the group here, I can actually go in here and select each of those icons that was in the toolbox anyway. Okay. So I have sources, the basics, my CMOS, TTL, my power. Okay. So we're going to go with the source, power sources, and we're going to put an AC power source in here. All right. It gives us some information around the power source here, but once we have it selected in the component window, click OK, and that allows us to drop it onto our work area here. Okay, you can see this one here has come in at 120 volts RMS and 60 hertz 0-degree phase shift. We'll go in there and we'll adjust those values to what we want in a moment. Right? But once you've dropped the component onto the work area, then the components window pops open again, all right, automatically, so that we can continue to select different components. So I'm going to go to the group here and I'm going to select basic because I want to find a resistor. So down here I have my resistors. All right, and again, I have values here for different resistances. Um, so I can go here and I can find the resistor I want and select the value, or I can just pick any arbitrary value here, click OK, put my resistor on circuit or on the work area, and again, it actually popped up here, so I can put it in. I can put in 1K. Okay, so if I put in 1K there, that's going to give me a 1 kilo ohm resistor. Right, and there's no need to put in the ohm symbol; it's already exists over here. All right, so I can just, once I've entered that, then I can hit the enter or the return key on the keyboard or click OK on the image. You can see I've changed to a 1K resistor here. And again, my component windows popped open again for me to select something else. So as I said, I was going to put an inductor in here. So let's select an inductor and just click OK. And I can place my inductor in here. Okay. Again, I can go in here and I can change the value on that in a moment if I want to. Uh, one more component that I'm going to use in here is just a switch. I want to be able to turn on and off my circuit. So I have my switches here. All right, single pole, single throw. That'll do me. Click that, and we'll drop this in here. And one final component that we need, and we need this for the simulation, for the in Multisim, is we need to put an earth in here. Okay, so if I go back to my sources, I can go to my power sources and ground. So I put in a ground connection here. I will need this for the simulation. It'll give me an error if I don't have a ground in there. Right. Once I'm finished selecting my components, then I can just click the close on the window here or hit the escape key on my keyboard, and that will allow me to move on and select what I want. So now what I'm going to do is I want to set my circuit up. So I'm going to click on this here. If I right click, okay, I can rotate that component. So I'm going to rotate it clockwise, bring it up on the vertical, and I shall right click on the inductor and rotate that clockwise as well. And then I'm going to bring them down here a little bit just to create a little bit of space so I can put the instrumentation in here, so that we can see what's happening in a moment. Okay, on the switch here, oh sorry, on the switch you can see that it has key equals space underneath it. That's when I get into the simulation. If I press the space bar, you can see that it closes it. Okay, again, if I double click on this, I can change what key I want to actually run that simulation. Okay, or to activate that component within the simulation, sorry, I should say. Okay, I'll just cancel that there. To connect up components then, I just simply need to mouse to the end of the component here. You can see where my mouse changes shape there to a connection tool. Okay, and I can come up here and you see the red dot. And once I get that, I can click there and that will create the connection for me. All right. If I want to put a shape, all right, so if I click on the lower end of the power source here and I go straight to the inductor, if I want to create a more defined shape there, I can just click on free space as I go across here, left clicking on free space, and that allows me to put a shape into my connections. All right, so I just continue to left click here till I get all my components connected up. So now I have them all connected. I want to change the value on my components here. All right, so my power source first. Double click. I can put in my voltage, my RMS voltage there. I'm going to go with 5 volts. And I can put in my frequency here as well. All right. I'm going to go with a kilohertz on this one, so 1K for the kilohertz. All right. And you can see here that I can put a phase angle in here. So if I wanted to put my supply voltage at a phase angle, I can put that in there as well. For this exercise, we leave that at 0. So I just click OK. My resistor value, I'm just going to change that. So just double click on that, and I'll put in 40 ohms on this one. Okay, and the inductor I'm going to make 5 millihenries. So 5 small m will give me 5 millihenries. A large m obviously would give me mega henries, and for the old inductor we won't go with the mega henries anyway. Okay, so that's my basic circuit completed. All right, with my components on there, and we've changed the values in the component. Actually, sorry, one last thing to do. Let's connect up the earth. So if I just bring the earth up here, you can see you get the red dot. That's our connection, our node, and away we go. So now that we have our circuit built, we want to put some instrumentation in here. So to the right hand side, we have our instrumentation tool panel. So we'll put a multimeter in first. So if we click on it here, okay, then we can move it in. So a single click there gives me the instrument, and I can just move it in here and place it wherever I want on the display area, the work area. So just click to drop it then. And once I have it dropped, I see I have my plus and minus terminals here on my multimeter. So I'm just going to click on that, and I'll bring it over here, and you can just see the red dot appearing there. It kind of hides behind the mouse icon. Once I have the red dot there, I'll get a connection. Okay, and again, we can do it with the negative to here. Right? So what I'm doing here now is I'm measuring the voltage drop across the resistor. Right? If I double click on the multimeter icon here, then I'll get my multimeter readout. Right? I'm measuring voltage here, and I'm measuring it on an AC system, so I need to click on voltage and AC. All right, and that will now give me an AC voltage once I run my simulation. So the multimeter is relatively straightforward to connect up. We can also measure current. Okay, again, it's where you connect up your probes for the current. Make sure when you're connecting up your current probes that it goes in line, it's in series with the circuit. Okay, whereas your voltmeter obviously is in parallel, as we've done there. The other thing we're going to do for this one is I'm going to connect up an oscilloscope. Okay, so I'm going to go with the standard oscilloscope, the 2-channel one. We'll bring it down here, and again, just drop it where you want it. Okay. On our oscilloscope, the 2-channel one, you'll see that we have two channels. We have channel A and channel B, and in each channel then we have two connections. All right, we have the positive, which is our probe, that is our sensing probe, our measuring probe. Okay, and then we have a negative, and that in this case is going to be connected to ground. Okay, and it will need to be connected to ground. So again, if I click on the probe, the channel there, and I'm going to put it down here, and then I'll bring it up. Oh, click here, just to give it some shape, and click into my circuit here, and then I can bring my 0 over here and tie it to ground here. Okay. We also have a trigger over here for if we wanted to connect up an external trigger. We won't be connecting up an external trigger for what we're going to be doing with it. Again, double clicking on the oscilloscope. All right, we'll open up the oscilloscope window. Let me just move it down here so we can see it. And within the oscilloscope window, then we will get our plot in the window there once we start to run the simulation. Okay. We also have our horizontal and our vertical channel adjustments here. What we'll do is we shall run the simulation, and while it's running, we'll have a better look at that, and we'll see what we can do with the vertical and horizontal channels in there then. Okay, so we're pretty set up here. We're pretty much ready to go. What I'm going to do now is I'm going to hit the run up here for our simulation. Okay, and that starts our simulation of our circuit. All right. So you can see our scope has come on. We're seeing our grid lines on our scope, and you can also see we have a red trace running along there. Okay. I don't have a trigger on this here, so you can see it runs to the end, stops, and comes back again. Now, one of the things with the oscilloscope, especially if we're going to be using the two channels, or when you want to run the four channel scope and take some more readings, is the trace colors in here. So currently the trace that I have is red. Okay. If I stop my simulation here, if I want to change things in the circuit, I need to stop the simulation. I can change them and then start the simulation again. I want to change the trace color here. To change the trace color, I need to change the color of the wire that connects that probe. Okay, and that's very simple to do, and I can do this on any wire in the circuit once I have it built. So if I go to the wire and I right click on the connector, and you can see segment color comes up here. So I can click on segment color, and I shall make it blue for this exercise. And just click OK. So now you can see on the schematic, the wire has gone blue, and if I run my simulation now, you'll see that my trace has become blue here. Okay, I might just the default on this is the black background. Okay, if you click reverse down here, it becomes the white background, and sometimes it's easier to see the traces on the white background, sometimes it's not, but we'll leave it like that for the moment. Okay, obviously our trace here is on the 0 line because my switch is open, so my circuit's not closed. Okay, and you can see on my multimeter I've got 2 microvolts because again my switch is open. If I press spacebar on my keyboard, okay, just one thing to be careful of is I have selected the scope window here. If I'm going to be interacting with the circuit, I need to make sure I go back and click on the workspace here to re-highlight that window. Then I can press the spacebar. That will close the switch for me. And you can see here now that I've got 3.927 volts being dropped across my resistor. You can also see that I'm starting to get my trace here for my, I suppose essentially what we're measuring here is, or we're looking at here, is the voltage trace across the inductor. Okay, so my trace here, very tight together. All right, so we're going to work on the time scale. So the time scale is your horizontal scale. And we can come down here and we can select on, it's at 10 milliseconds per division. So that means that each box here is 10 milliseconds. Okay, so if I select that, you can see I get the increase decrease, and I can change it. So if I increase it, I have more milliseconds per division. All right, and if I decrease it, less milliseconds per division, so I get to see the signal a little bit better. Okay, so now you can see it's jumping quite a lot there. Okay, because that's what the AC signal is doing. It's running continuously. And with the simulation, we do get a sort of a little bit of a lag there, so that's why it kind of jumps. But what we wanted to do to sort this out is go down here and select our trigger. Okay. And our trigger essentially is looking for a repeating pattern within the signal, and then it'll lock onto that repeating pattern and it'll represent the signal to us based around that repeating pattern. All right, so I have no trigger here at the moment. I can auto trigger, okay, which doesn't appear to do a whole lot for us there. I can normal trigger, or I can single trigger. Okay, so if I single trigger, what it's done now is it's looked at the wave. Okay, and I'm holding this point, but if you look at the the scroll bar here, it's getting smaller and smaller. That's because the signal is running out to the right hand side. So if I take this and I go to the right hand side, it doesn't look like the signal changing, but it is actually changing. Okay. Um, the other things that I can do here is select which channel I'm triggering off. So I have my signal on A and I'm triggering off channel A. Okay. And I can also trigger on the rising or the falling edge. Okay. So we go. Um, the normal is probably the better one here because what we'll do is we look at it, and then we can stop it. We'll run it again and try and get it stopped on a bigger screen. Will I get my timing a bit better? No. Okay. We'll run single, run it, and stop it. Okay. That's enough of my signal for the moment. I can still manipulate the scope now to look at that signal. So I can change my divisions here, and I can look at a more attenuated signal. That's, as I said, the time base is my horizontal, and then my channel A and my channel B, they're my vertical. All right, so I only have channel A, so I don't need to worry about channel B at all for the moment. And if I change the scale on channel A, okay, currently it's 5 volts per division here. So if I decrease that, it's 2 volts per division. You can see that I'm attenuating in on my signal, and I'm getting a better representation of it. The other thing we want to look at here then is our cursors. Okay, so this is our information here on our cursors. So we're going to take these are the two cursors up here. You can see we have an orange and a teal one, I suppose. Or sorry, a yellow and a teal one here. And these are our two cursors. And if we move these, we can take measurements off the screen. So if I move this cursor here, um, it appears to be currently, so this should follow a trace, which it's not. So if we right click on it, okay, we can select the trace. Okay, and I'm going to trace on channel A. So it was following the axis there at the moment. So I'm going to trace to channel A. And now you can see where I got this little circle where the cursor crosses the trace. And as I move across the trace, you can see that moving. Okay, so we'll use that to set up, we'll say a zero crossover here, and then we can move the other one to this zero crossover here, as close as we can. Okay, and now between the two cursors, so T1 is the first cursor. All right, I can see what time it's at, and I can see the voltage value that it's at. Okay, this is minus 55 millivolts. T2 is at 1.49 milliseconds, and it's 100 millivolts, thereabouts. Okay, um, and the bottom down here, T2 minus T1, gives us the difference between them. Okay, so it's giving me the relative difference between them. So this is one where we can use to measure the phase angle. So if we have our two traces there, and we measure let's say the negative going zero crossover on both traces, then we will be able to measure the time between that, and looking at the time, then we'll be able to calculate our phase angle from that. Okay, so we've done our circuit. We've built a simple circuit. We've used the multimeter, and we've set up and hooked up the scope. Okay, and we've also looked at going through some of the settings in here, the key settings in this on the oscilloscope that we're going to need. All right, and that is pretty much the basics of what we want to do with the Multisim software package.